Good day, grade 12 learners. Welcome to today's technical mathematics lesson. My name is Moses Maudu. This lesson is brought to you by the Gauteng Department of Education in collaboration with Saibono Discovery Center. Today's lesson will be on analytical geometry, which is paper 2. The objectives of today's lesson are, after the completion of this lesson, you will be able to determine the distance between the 2 points, and to be able to determine the coordinates of the midpoint of the line segment joining the points. Must also be able to determine the equation of a straight line joining the 2 points. The next one, you must be able to determine the equation of a line through one point and parallel or perpendicular to a given line. Number 5, you must be able to calculate the angle of inclination of a line where m is the gradient, which is equals to the tangent of theta and is the gradient of the line. The next one, you must be able to determine the equation of the circle. Number 7, you must be able to determine the equation of the tangent to the circle given one point of contact. The last one, you must be able to draw the ellipse in the form x squared over a squared plus y squared over b squared equals to 1. Now in analytical geometry, you'll have a formula sheet. There will be a formula sheet at the end of your paper. But the formula sheet that talks to the analytical geometry are the following. So these are the ones, some of the ones that you have done in grade 10 and grade 11. The distance formula, the midpoint formula. We also have the gradient formula and the inclination of the line. So you realize that I did not put the equation of the straight line, because the equation of the straight line formula is basically the same formula as this one, but we can just put it in there. So that formula will be y minus y1 equals to m into x minus x1. So that's the formula of a straight line. So the formula of the straight line, that is when you're given 2 points, that formula we can get it by just cross multiplying this. So which is m times m into x2 minus x1, which is more or less the same as that. And the y2 minus y1 is the one that I've written there. So y minus y1 equals to m into x minus x1. The last formula is for the inclination. This formula, we only use it when we have an angle which is formed between a line, straight line, and an x-axis. So we are only going to use this formula when I have the angle which is formed between the straight line and the x-axis. So if I've got a line like this going that way, so it is between the x-axis and the straight line. So can you see that is that formula will only work there. The m equals to the tangent of theta, because remember the tangent is the change in y over the change in x, which actually represent the gradient of the line. So the gradient of the line is change in x over the change in y. Change in y over the change in x. So the gradient there is represented. And remember, tan, it's when we go into trigonometry, tan is y over x. So it's the change in y over the change in x. So that's why the tangent of theta will be equal to the gradient, because the gradient is also change in y over the change in x. Now, going to the activities, the equation of this, the circle, will do it later on. Going to the activities, the first activity there, in the diagram, we are given AOB as a triangle. So the AOB is a triangle with the vertices. The A is 15 and 8, and B is 23 and 5. So now the coordinates of O, which is the origin, it's 0 and 0. Beta is the angle that is formed, is the angle of inclination of OB. So OB is that line, beta is that angle here. Now, and alpha is the angle of inclination of the line AB. So in other words, from here to there, that angle there, it's alpha. So now we need to determine the gradients of OA and the gradient of OB. Now, how do I get the gradient of OB? Easy. If I've got a line from the center to that point A, obviously at the center it's 0, 0. Then we have 15 and 8. Then it means that it will be change in y over the change in x. If I can just write down the gradient of OA will be the change in y, y2 minus y1 over x2 minus x1. So for me to get a gradient of OA, that point here is 0 and 0. So we're going to have a 0. So I'm just going to write that point here, 0 and 0. We're going to have an 18 change in y, 18 minus 0. So it will be 18 minus 0 divided by 15 minus 0. Remember, we start with the y. And 15 minus 0. So we're going to get 18 over 15. And if I simplify this, 3 goes 6 times into 18. And 3 goes 5 times into 15. So I'll have the gradient of OA as 6 over 5. Right. I know I'm correct because the gradient of that line there is a positive gradient. So the answer should be positive. Now, to get a gradient of OA, so I want to explain the issue that I was saying, the point that I was saying, that we have the line, the line starts at the center. So if it starts at the center at 0, 0, it goes to that point which is 23 and 5. So the gradient of that line will still be the same. So the gradient of OB will still be the same. So it will be 5 minus a 0 and 23 minus a 0. So actually, I'll just have 5 over 23. So as the gradient of that line. So I can just take the 5 and divide it by 23, but only when the point here is at 0 and 0. So we can just write that down. Okay. All right. But please, when you're practicing, you must write that down. It must be 5 minus 0 divided by 23 minus 0. Or 0 minus 5 divided by 0 minus 23. So if you start with a 0, then you must, at the numerator, you must also start with a 0 at the denominator. Easy. Okay. The next activity, determine the angle of inclination. The angle of inclination there. So the angle that we need there is the angle beta of the line OB. So if you look at OB, so the angle beta, so the OB and the x-axis, so the angle that is formed there will be beta. So they just wanted to confuse you there. That which angle are you going to calculate? Is it alpha or is it beta? But we can see that that angle that we need to get there will be angle beta. So that's that small angle there, because the angle of alpha, it goes right to OA. So we need an angle of inclination of the line OB. So which means I already know the gradient of OB. Sorry. Just quickly go back. I already know the gradient of OB. So the gradient of OB is 5 over 23. Now I need the angle. How am I going to get the angle? So remember, the angle will be the tangent of the angle, which is this time beta, will be equal to the gradient. And the gradient of that AB is 5 over 23. Okay, so the gradient of OB we know, so we need to find the angle now. So obviously, to get the angle, you go to your calculator, then we go to shift, tangent, then we put a fraction button, then So the fraction button, we put 5 over 23, we close the bracket, then we say equals to, and our angle will be equals to 12,3 degrees. Correct one decimal place in that case. So we have an angle now of beta, which is 12.3 degrees. We can see that's a small angle here, so it gives us 12.3 degrees. And that's all that we want. Okay. Find the size of AOB. Now, we already know that this angle here, it's 12,3 degrees. Now we need this angle AOB. So if you look at that angle AOB to the nearest whole number, so we need that angle actually. We need that angle here. We need that part here only. But I can see we have that angle there. So for this angle here, I cannot use the tan for that angle. So I must do something. I know this is a triangle. So I must do something with that angle. So first I will try to get angle alpha. Once I get the whole of alpha, which is from here to there, I can remove this one. I can remove this angle here. If I've removed this angle, this part here, then I'm left with AOB. Let's do it. Find the size of AOB, correct to that. So let's see. First of all, I must get the angle alpha. So angle alpha will be equals to, remember the gradient, it's 6 over 5 for OA. So if I get the angle of alpha here, so I'm going to get, and that's a positive angle, so that's not a problem. I get 50,2. Remember, I go to shift tan, 6 over 5, and then I'll get the angle. But the angle that I got now is that whole angle, which is 50,2 degrees. So for me to get this other angle here, I need to subtract this small angle here. So I'll go AOB. Can you see now for AOB, I'm not using any formula for tangent equals to the gradient, because that formula, that angle here, it's not between the x-axis and the line. It's between those lines AO and OB. So I'm going to say AOB will be the whole angle 50.2 degrees minus 12,3 degrees. Then the angle that is left will be 37,9 degrees. But they said this is approximately that. But they said we need to write down, correct that to the nearest whole number. If you don't do that, then you lose that mark. So it means that to the nearest whole number, that we need to write it as 38 degrees. Okay, so now we know that AOB is now 38 degrees. All right, very interesting question there. Okay, so now let's look at that. Now, the other thing is knowing your terminology. Now, perimeter. We need to understand what perimeter is. So we're looking for the perimeter. In other words, of triangle AOB for this triangle here. So perimeter means that we need to get the length of this side, the length of that side, and the length of that side. And we add all the lengths. And then from there we'll get the perimeter. So it's the length around the figure. So the distance around the figure, that's the perimeter. So I need to find the length of OA. So which means I need to find the distances. So first of all, I'm going to find the length of OA. So for me to find the length of OA, remember the formula, it's OA, and I put a square root. So it's equals to the square root of that. So for OA will be 18 minus 0. Remember, this is 0 and 0. So it's 18 minus 0 all squared. Then we'll have plus 15 minus 0 all squared. So the length of this line here will be 18 minus 0 and 15 minus 0. Okay, we start with the x value, so it will be 15 and then it will be 18. So it's 15 minus 0 because that's x minus x1, x2 minus x1, y2 minus y1 all squared. So for me to do that, you just go to your calculator. Please do not work in bits and pieces when you are trying to calculate something on a calculator. So, which means I must just go to my calculator, press square root sign, open bracket, 15 minus 0 all squared, plus open bracket, 18 minus 0 all squared. Then it gives you the answer. So the answer that I'll get here, it's 3 root 61. That's what the calculator will give me. Then from there, go to OB and I do the same. The square root of, for OB, it will be 23 minus 0 plus 5 minus 0 squared. Then from there still, I then go to the calculator, put everything in a calculator, and the answer that I'm going to get there will be square root of 554. 554. Same applies to the length of AB. I'll do the same with the length of AB because I need all the lengths for me to get the perimeter. So the length of AB, I'll then go the square root of. Then in this case here, I'm going to have 15 minus 23 squared plus 18 minus 5 squared. So it's 15 minus 23 and 18 minus 5. Then from there, the answer that I'm going to get there, it will be the square root of 233. So if I go to my calculator and write, to my calculator, I need now the total perimeter. So now I need the perimeter, right? So the perimeter will be 3 root 61 plus square root of 554 plus square root of 233. Then the perimeter, then I'll get my perimeter. So if I add all those using a calculator, the answer that I'll get there is 62.23 units. Remember, it's not square units. We are only adding the lengths. So these are units. We just write units there. So there we just write units. There we just write units. Then we add all this, we get units because you are adding. There's nothing that you are multiplying to get a square or something. So perimeter, units. Okay. Right. Now let's look at activity 2. Now you'll see in this type of questions, which formula did we use actually? We have used the gradient formula, we have used the inclination, we have used the distance formula. So those are the formula that we have used. So if you get those formula right, you already have 3 marks on that question, just the formula only, because you'll have written the formula for the gradient, you'll have written the formula for the inclination, you have also written the formula for the distance, you'll at least get up to 3 marks from that before you substitute, before you do anything. So please know your formula. In the next one, you'll see same principles. In the diagram PQR, in this case now POR, this triangle should be PQR. That's PQR with vertices P, it's given 5, minus 5 and minus 2. Q, it's given minus 1, minus 6. R, it's 5 and 4. N is the midpoint of that. And then we have point S on the y-axis. So all the information that I've read through, that information is indicated on the sketch. So I do not have a problem with that. But I must first read the information to see that everything that is there on that information, it's indicated on the sketch. Now, the first question says, determine the gradient of PQ. So now I'm using point P and point Q to get the gradient. So I'll write M gradient of PQ equals 2. So the gradient of PQ will be y2 or y at P minus y at Q divided by x at P minus x at Q. So what does this mean? It means I need the y value at P. So the y value at P is minus 2. So I'm going to start there. So I'm going to say the y value at P is minus 2. The y value at Q is minus 6. So remember, there's a minus for the formula and there's a minus for the value divided by the x value at P, it's minus 5, minus the x value at Q, it's minus 1. So now from here, just use a calculator. Just go to your calculator, put a fraction button, minus 2 minus into minus 6 over minus 5 minus into minus 1 in your calculator. Because I know we make a lot of mistake trying to multiply out the negative and the positive, and from there we make a lot of mistakes writing down the final answer, and we're losing marks on that. And we have a gadget that can help us to get this marks. So just go to your calculator, put it as it is, and the answer that we're going to get there will be negative 1. So which means that the gradient of that line there will be equals to negative. All right. Now, in this question here, activity 2, first thing, we know the formula for the gradient. We have got a mark for the formula for the gradient, substitution there. Now, the next one says, determine the coordinates of n. Remember, we were told that n is the midpoint of this line. So if it's the midpoint, you go to your formula sheet, go to the formula for the midpoint. The formula for the midpoint, I know the coordinates for the formula of the midpoint will be x1 plus x2 divided by 2 and y1 plus y2 divided by 2. In this case, we're talking R and Q because the n is between that, is the midpoint of that line. So which means that we're going to have our ns or x1, x2, we're going to have a minus 1 plus a 5, minus 1 here plus a 5 over 2. Then we're going to have a negative 6 plus a 4 all over 2. And then the point n, coordinates of n are going to be, I see it's 5 minus 1, which is 4. So 4 divided by 2, it's 2. Then there we have a 2 minus 2, so we're going to have a negative 1. I go to my sketch. That's very, very important, boys and girls. You go to your sketch and check. Can this point, can the value of x be 2? Yes, it can be 2 there because it's on the right-hand side of the x-axis. Can the value of n be negative 1? Yes, because it is just down there here. So that's how I make sure that my answers are correct. If I got something like negative 2 and 1, then negative 2 will be this side and 1 will be that side. Can you see? Then I can know that that is not correct because the n value, the end point is on the fourth quadrant where the x value is positive, the y value is negative. All right. Now, the next one, determine the equation of the line parallel to PQ passing through R. And that's where we have a lot of problem because of the language. But I need to just underline the keywords. The keyword there is I need an equation. So if I need an equation, it means that I need an equation y is equals to mx plus c because that is a straight line that I'm looking for. Now, the other thing is the parallel. What do I know about parallel lines? So parallel lines are lines that that have got the same distance in between. Okay, and they will not meet. Okay, so which means I need to draw a parallel line to PQ. So here's my PQ. So there must be another line which is parallel. So that line that is parallel must pass through what? R. Where's my R? Here's my R. So meaning that the line that I need is the line that passes through that. And it must be parallel to this line. That's what parallel means. So these two lines are going to be parallel. But now, what do I know about the gradients of parallel lines? It must be in your notes, my boys and girls. It must be there. The gradients of parallel line, the gradient of line 1 must be equal to the gradient of line 2 if the lines are parallel. Only if they are perpendicular, it's when we have the gradient of line 1 times the gradient of line 2 giving us -1. In this case, they must be equal. Do I know the gradient of this line? Yes, I got it somewhere in question 2.1.1. Go back there. So the gradient of that is -1. What do I know about the gradient of that line? It's equal to the gradient of that. So it is also going to be -1. So already I have the gradient of the parallel line. So the gradient of the parallel line will be -1. And I've got a point, which is point R, because that line is passing through that point. So the point R is 5 and 4. So I'm done with my equation, because then I need y minus y1 equals to m into x minus x1. Just by writing that equation, you're going to get a mark. So then I'm going to have y minus 5 equals to the gradient is -1, y minus 4, because it's y1, this is my y1, and x minus 5. So I'll have y equals to -x. Negative times negative is +5. Transpose the -4, it becomes +4. Then my y will be equals to -x plus 9. How do I know that I'm correct? That line is a decreasing function, so it is a negative gradient. That point up there, if I continue with my x-axis there, my y-axis, that point up there will be 9. Okay, which is +9 in this case. So my y-intercept will be +9. So I know at least that that answer is close to what they're looking for, or it's what they are looking for actually. Okay. All right. Now the next question. These are some of the questions that I know my boys and girls you skip. I think that should be PQ over SN equals to 2. I think there's a 2 missing there. These questions that we always skip where we say show that. Already we are giving you the answer. The answer is PQ over SN, it's 2. But we need to you need to show using the analytical methods, and that's where we have challenges with. Using analytical methods means that we either use any of the formulae like the gradient, we can use the distances of the length of those lines. So in this case, I can see PQ is a line. So I can get the distance of that line. SN is a line. Do I know the coordinates of n? Yes, I got the coordinates of n somewhere, which is 2 and -1. So I have the coordinates of n. So I want to check that if I take the length of PQ and divide it by length of SN, will I get this number? That's what this question wants. So which means I need to get the length of PQ. I need to get the length of SN. And then from there, I must check if PQ over SN, what answer will that give me? So first of all, I need the length of PQ. So the length of PQ will be 5 minus 5 minus -1. So I'll say -5 minus minus 1 will be plus 1 squared, plus minus 2 minus 2 minus minus 6, so it will be plus 6, and that's squared. So the answer that I'm going to get there will be, in my calculator, will be 4 root 2. So that's what I get. Okay. Now for Sn, I'll need 2 minus a 0 squared. So 2 minus a 0. 2 minus a 0 squared plus minus 1 squared. Then if I do that, then I get the square root, 2 square root of 2 as my answer. Now, I'll take the PQ that I got there. So the PQ that I got was 4 root 2. Remember, I already have an answer, which is 2. So I'm just proving that that answer is 2. The next, the Fn is 2 root 2, which means the square root of 2 and the square root of 2 will cancel out. 2 goes once there, 2 goes 2 times there, which means that our PQ over Sn will be equals to 2. And we have proved that. So when we say show, it means that I must then do some calculations. Am I using analytical methods? Yes, because I'm using the formula for distance, and the formula for distance is an analytical geometry formula. So the analytical geometry formula that I've used is the distance formula. So I've used the distance formula and I've proved that. You can still use other methods here. You can also use the gradient of those lines. Then from there we can also use the, but they said analytical methods. Okay. I know some of you know the midpoint theorem, because that formula will basically be the midpoint theorem that you have done in grade 10. All right. Now, activity number 3. In activity number 3, we still have, and if you can look at what I've done now up to so far, activity number 1 and activity number 2, there's nothing grade 12. So this is grade 10 and grade 11. So can you see that we've got a lot of work that you need to go and revise from grade 10 and grade 11. Because we have already done the distance, we've already done the perimeter, we've done the gradient of the line, we've done the equation of the straight line. And that is what we have done there. And the midpoint, the formula for the midpoint of a line. So that's grade 10 and grade 11 only. So you can see you can get marks from grade 10 and grade 11 work. So you just need to go back and revise your grade 10 and grade 11. Still on this one, it's the activity 3. We still have grade 11 work. So you can see the different ways on how they put the diagrams. Okay, this one now you have a 4-sided figure, which is a parallelogram. They told us that this is a parallelogram. So what do I know about the parallelogram? Opposite lines, the opposite sides are equal and parallel. See, that side and that side will be parallel, and that will be parallel and equal. It's a parallelogram. I'm already told some of the things I'm told in the information that is there. Okay. Now, A coordinates are there, the B coordinates are there, the C coordinates are there, the F coordinates are not there. Right. So we have got A, B, and C coordinates, but F, we don't have any coordinates in there. Let's see. Let's go with the question. Now, the length of AC. Determine the length of AC and leave your answer. This is very, very important, my boys and girls, that we have to read the instruction that is given, especially on the questions. The length of AC. So in other words, we need to find the length of AC. So the length of AC will be, and your calculators are very clever, because your calculators will then immediately, if you say square root of 8, then you say equals to, it will give you 2 root 2. So that will be in a simplified set form. So the answer is there on your calculator. But I know with many of us, we will go and press SD, and SD goes to decimals, and then we might get wrong because the question wants you to write the answers in simplest set form. So you must read the instruction. Very, very important. Because once you go to SD, it gives you as a decimal. We know it is correct, but we don't want it that way. We want it in simplified set form. If you go and write square root of 8, we'll give you we'll subtract that mark because you are not doing that question according to the instruction. Now, enough of that. So AC, it will be equals to the square root of, so I'll go 4 minus 2 squared plus minus 5 minus 3 squared. So if you check this here, for AC, we're taking AC. So it will be 4 minus 2 squared and minus 5 minus 3 squared. So the answer that I'm going to get, if I put this in my calculator, immediately it will give me 2 root 17. And that is in a simplified set form. If it is not in the simplified set form, then it's going to give us 17 multiplied by 4. And the answer that is we're going to get square root of 68. And if you write the square root of 68, you'll lose that mark. If you write it as 8,25, you'll lose that mark. So in other words, the only answer that we want, it's 2 square root of 70. All right. The next one, 3.1.2, we're still on the same sketch. Determine the equation of the straight line in the form y is equals to. So this one is very specific in terms of how we want the equation of the line to be. So we need the equation of the straight line. For us to get the equation of the straight line, what do we need? First, we need a point. Number 2, we need a gradient. If I know the gradient of this line, so we need the straight line AC, we need the gradient of that line. From the gradient of that line, we also need 1 point. In this case, we've got 2 points, no problem. We can choose one. I don't prefer choosing the one with a negative because we make a lot of mistakes. So the one with the positive, better. So now I'll have the equation of the straight line AC. First, I must get the gradient of AC. And the gradient of AC will be, remember, it's minus 5, minus 3, all over 4 minus 2. So that gives us negative 8 over 2, and that will be negative 4. So that is the gradient of that line. So we know the gradient of that line is negative 4. I now need a point, so I can use that point. As I said, this point, we can still use it. If you are brave enough, you can use the one with a negative. But I prefer that we use the one with both positives because it's easier to do. And that's me. So y minus y1 equals to m. Remember, we need the equation of the straight line, AC. Y minus, so I'm using this point here, so it's y minus 3. No problem with the sign. The gradient is negative 4. X minus 2, no problem with the signs. I'll just deal with the signs when I'm multiplying. Minus 4x plus 8 plus 3. I've just transposed this one. So the equation will be y equals to negative 4x plus 11. So if I want to know that I'm correct, the gradient there, it's a negative gradient, decreasing function. The point there, 11, will be somewhere there. If I extend this, my point 11 will be somewhere there. No, I am correct. If I got a negative 11, I'll know that, this point will never be there. So I know there's something wrong with my signs, so I must go and check my signs and see where I went wrong. Right. Still in the same activity, can you see they give you one sketch and they ask you questions from the sketch. And this is, as I say, it's still grade 11. Now, determine the size of theta. Now, here's my theta. How is it formed? Between a straight line and an x-axis. So immediately when I see that the angle is formed between a straight line and the x-axis, I then go to tangent of that angle equals to the gradient. Okay. Do I know the gradient of that line? Yes, I think we got the gradient of AC because it's between the AC. So it's -4. Now we have a challenge. So the gradient here is -4. For me to get the angle, once I see a negative, then I put a reference angle. So in my gradient, once I see a negative, I put a reference angle. Why? It is because that angle is going to be bigger than the one that I'm going to get now. So it means I'm not going to use the negative. I'm going to use the reduction formula 180 minus. So I'm not going to use the sign, the negative, when I go to my calculator. Easy way to do it on my calculator is I'll go to my calculator and say shift, turn, then I'll go and press 4. So if I press 4, the angle that I'm going to get will be 75.96 degrees. All right. Now, this is not the value of theta. You can see there I did not write theta because it is not the value of theta. So my theta will be, so I'll go to my calculator and say 180 degrees minus the reference angle. So I'll go to my angle, it will be 180 degrees minus the reference angle. Then the answer that I'm going to get now is the correct value of theta. Right? So we can see that that angle can never be 75 degrees. Because if I just draw a line here, that will be around 90 degrees. So you can see the angle is more than 90 degrees. Cannot be. It's an obtuse angle. So it cannot be 75 because 75 is an acute angle. So remember, acute, less than 90 degrees. Obtuse, more than 90, less than 180. Okay. The next one is an interesting one, where we need to calculate the coordinates of G. I don't even have the coordinates of F. What was I told about G? We were told that G is the midpoint. If we go back and check our statement there, G was the midpoint of it. So for me to get the midpoint, so in other words, I'm not going to use this line. I'm going to use this line. Obviously, I'll know that point here. That point is the value of x I already know. The coordinates of, the value of x I already know. Why? It is because this point here, it's on the y-axis. On the y-axis, x is 0. So I don't have to calculate it. Or for the sake of us checking, let's see if we calculate it. We're going to say G coordinate. Remember, it's the midpoint, so we're going to say x at B plus x at C. Remember, we're using these points here. Over 2 and y at B. Remember, with this is a plus. With midpoint, it's a plus. So then we're going to get the values now. The y at B, so the x at B is -4. The x at C, it's +4 all over 2. Do you see why I said the first point will be 0? But let's continue. Y at B, it's 2. And then y at C, it's minus 5 over 2. So now, minus 4 plus 4 is 0. 2 minus 5, it's negative 3 all over 2. So can you see that that point here is 0? As I say, it is on the y-axis, so the x value. I did not need to calculate that one because I can see that that point, we are told that that point there is a y. It's on the y-axis. So that point, so now we have, how do I know that I'm correct? This one is on the y-axis. The point of y is minus 3 over 2, so it's below the x-axis, below the 0, which makes sense that that point will be minus 3 and 2. All right. The next one is also a challenge. I already have this point here, which is 0 and minus 3 over 2. Now I need the coordinates of f. To get the coordinates of f, I already know that if I draw this line here, and I'm told that A, B, F, C, it's a parallelogram. I've been told it. So the coordinates of F, I don't have. The coordinates of G, I have. The coordinates of A, I do have. And you can see the way the hands means that use what you got in the previous one to do this one. So in other words, my previous question was to get the coordinates of G. So I'm using the coordinates of G. So, but I know with parallelograms, the diagonals bisect each other. So in other words, this line here and that line will be equal. This line here and that line will be equal. So in other words, that point here will be the midpoint of those two diagonals. If I was not told that this is a parallelogram, then I'll be having a very big challenge. Unless if I'm told in this question that G will be the midpoint. So now, let's check. So which means I'm going to use my midpoint formula. So my midpoint formula is x equals to x at A plus x at F over 2. That is for my x value. Remember the midpoint, it's if I need to find the other coordinate, then I have to do it this way. The other one on the side will be y is equals to, remember I need this point, I don't need the midpoint now, the midpoint is given. So if the midpoint is given, then I need to use this formula. So it will be y at A plus y at F all over 2. So for me to get the coordinates of that, so the x here is the value of is the point there on G, which is the x value at G. So which means this will be 0. X at A is 2. I don't know what is x at F because that's exactly what I want. So I don't know what that. All over 2. So if I cross multiply, I'll get 0 equals to 2 plus x at F. So now my x at F will be equals to negative 2. So I've just taken that other one. Similarly with the y, I'll say my y point here on the midpoint, it's minus 3 over 2. My y at A, it's going to be 3. My y at F, I don't know. All divided by 2. Cross multiply, I'll get a negative, I'll get a 6. I'm cross multiplying there. So I'll get 2 times 3, it's 6. 2 times 3, 2 times y at F is 2 times y at F. Then from there, that will be equals to 2 times negative 3 is negative 6. So 2y at F equals to, transpose the 6 that side, you get negative 12 My y at f will be equals to, divide both sides by 2, we get negative 6. So the coordinates of f here will be negative 2 and negative 6. But I must still go back to the sketch and check. If I go to the sketch, I'll check the f value there, the f coordinates there, minus 2, will that one fit? Yes, it will fit because it's on the left-hand side of 0 on my x-axis. Negative 6, can this point be negative 6? Yes. So I know I'm correct when I have those two values. Okay, very interesting question, this one. And these are questions that we must get. We must practice them more because these questions are not straightforward. So we know how to get the midpoint of the, I mean the midpoint of the line. But when the midpoint is given, what do we do? This is what we do. Okay. The last question on question 3, on activity 3, determine if this line BC, it's perpendicular to this line. Show all your questions, your calculations. So we want to see if BC, this line BC, it's perpendicular to this line AG. We want to see if those two are perpendicular. We want to see if there's a perpendicular line there. What? Obviously, in a parallelogram, I don't think the diagonals will bisect at right angles. But let's see. Now, so let's see BC, we first need to get the gradient. Remember, for perpendicular lines, and we're using analytical methods, for perpendicular line, we need the gradient of BC. If the gradient of BC times the gradient of AG, remember the G point is 0 and minus 3 over 2. If the gradient of BC and the gradient of AG, the product of those two gives us -1, then we know they are perpendicular. But let's first get the gradient of BC. So you cannot write gradient of BC times gradient of AG equals to -1 and then work it out. No, we want to show, want to determine if, by the gradient of BC, how do I get the gradient of BC? So we'll have -5 minus 2 over 4 plus 4, right? So that 4 will be given -7 over 8. So that's the gradient of BC, right? So the gradient of BC is -7 over 8. Now we need the gradient of AG. So the gradient of AG will be -3 over 2 minus 3 all over 0 minus 2. Please don't stress yourself with multiplying out and all that. I know this is going to be 2 times 3, it's 6. -6, -6, -3 is -9. So on top there, I'm going to get -9 over 2. -9 over 2. I'm doing it manually, but please go to your calculator, and that's divided by -2. Then if I multiply this 2, if I divide this 2, I'll get +9 over 4. Now I can see that the gradient of BC times the gradient of AG, multiply this 2, I'll get -7 over 8 times 9 over 4. And this will never give us -1. If I multiply these two gradients, if they don't give us -1, we say therefore BC is not perpendicular to that. You should see it's not perpendicular to AG. Because the gradients, when we multiply them, they don't give us -1. So we'll just say, no, those two are not perpendicular. Write it in weights. Okay, right. Okay, we'll take a 2 minutes break, and then we'll continue with activity 4 and 5. Okay, welcome back. Now let's look at activity 4. Now, activity 4, it's grade 12 work, the work that we have done this year. So in activity 4, these are circles that we're working with. Now, remember in grade 12, we only done the equation of the circle. You have done the equation of the tangent to the circle. And we have also done the sketching of the ellipse. Now, let's look at this question, the first question. It says, the diagram shows the circle with equation x squared plus y squared equals to 13. That 13 here is r squared. Right. Now they say the contact point of the tangent is -2 and -3. That is the point that has been given. So meaning that that line is a tangent, we are told. That is a circle. So now, if r squared is 13, which means that our r will be square root of 13. Now here is the question. Write down the radius of the circle. So in simple terms, we're saying if the radius squared is 13, we need to write down the radius of the circle in simplified set form. So obviously in simplified set form, we're just going to take the square root of that and the square root of that, and that will be the square root of 13. If you write 3 comma something, then you not get that mark because that should be in set form. So the square root of 13 is in set form. So we cannot simplify it further. Right. 4.1.2. It says determine the equation of the tangent. So here is the tangent, passes through the point that. So here is our radius there. It passes through that point. That point here is 0 and 0. Now we need to find the equation of the tangent to the circle at point A in the form y is equals to. Now, firstly, I need the gradient of OA so that I can get the gradient of the tangent, which is perpendicular, you see? Perpendicular to the tangent. So first I'm going to get the gradient of OA, which is equals to. So it will be 0 minus -3 over 0 minus into -2. So the gradient of that line will be 3 over 2. That is the gradient of O. So the B value is greater than the A value. So that point here, B, square root of 9 is 3. So 3 will be greater than the square root of 3. So do not be confused here because there we have a 3 and we know the square root of 9 is 3. So, but here we need the square root of 3, which is going to be 1,7. 1,73. Okay, right. Still in grade 12. This is a very, very, very interesting question. I like this question because there we have been doing questions where we have a line from the center of the circle to that point. So we've been having something like this, you know. Most of the questions were like that. But now this line here doesn't start at the center. You see, it starts on the x-axis. So we cannot use that point and that point as the length of the radius. Can you see? Because that line is very short. That one is our radius because the radius is from the center of the circle to the circle. Can you see the trick? Now here it says in the diagram, the center 0, 0. ML is a tangent. So given that this line here is a tangent, we have a point on the tangent. M minus 5 and 12. And L is the y-intercept. You see, is the y-intercept of ML, of that tangent. D is the point on the x-axis, you see. Beta is the angle of inclination of MD. Is the angle of inclination of MD. MD is a straight line. And then we have an x-axis. So it's between the straight line and the x-axis. Then you know what you're supposed to do there. Now the question says determine the equation of the circle. For us to get the equation of the circle, we need a point on the circle. Now, so it means that we're going to have our equation x squared plus y squared equals to r squared. Then the point that is on the circle, it's minus 5 and 12. This point here, it's not on the circle. We can't use it. Then we're going to have x is negative 5 squared. Our y is 12 squared equals to r squared. For us to get the equation of the circle, we need r squared. Now, we're going to have a 25 here. We're going to have a 144 equals to r squared. Therefore, my r squared is 169. They didn't ask us the radius, they asked us the equation of the circle. Therefore, the equation of the circle is x squared plus y squared equals to 169. The mistakes that we're always doing is to get the square root of r squared. Then you get x squared plus y squared equals to 13, which becomes incorrect. So here, what we need to substitute by is the r squared here. So we're substituting r squared. Please do not get the value of r. You were not asked about anything about the radius. So please do not do that. The next question is determine the equation of the tangent in the form y equals to. Now I'm no longer going to go the route of getting the gradient and gradient of the radius and gradient of the tangent and all that. I'll go to that formula. But I know you can still go that route. If you go that route, it means that now you're going to have the equation, the gradient of the radius and get the gradient of the tangent. Then from there, use this point to get the equation of the straight line. That's a procedure. It's a very simple, straightforward procedure. For the sake of time, I'm going to use that quick method. So it's x minus, I multiply by x1 equals plus y multiplied by y1 equals to r squared. Please practice this method if you want to use it in the exam. So I have got my x1 here, which is minus 5x. The x is this one. Then I've got my y, which is 12. So I'm going to say plus 12y equals to the r squared is 169. So then I've got my 12y equals to 5x plus 169. I've transposed the minus 5x. My y will be 5 over 12x plus 169 all over 2. That is the equation of the straight line. You want to use that other method, please, I want you to go and use this other method, the method where you get the gradient of the radius and the gradient of the tangent. Use that point and then see if we get the same answer as the one that I got now. All right. Determine the coordinates of L. Now we have been told that L is the y-intercept of the graph. Don't think we need to determine those coordinates. The coordinates of L are just very, very simple because we know that L is the y-intercept of the tangent. We already have the equation of the tangent. The equation of the tangent is y equals to 5 over 12x plus 169 over 12. Obviously, this is the y-intercept of the graph. So the equation, the coordinates of L, the y-intercept 169 over 12, but it's the y-intercept, so meaning that the value of x will be 0. So we don't need to calculate that. We just need to write down the coordinates. Question was supposed to say, write down the coordinates of L, or hence write down the coordinates of L, because we will already know what the coordinates of L are. we're getting this by putting the value of x to be 0. So this time 0 is 0, and then y will be equals to 169 over 12. Okay, and that's how we get the coordinates of that. Now, this is a very interesting question also here. Obviously, for us to get the angle here, the inclination, the size of beta, we need this point here, we need that point there to get the gradient. So which means I need to first find the gradient of MD. The gradient of MD will be 0 minus 12 divided by -3 plus 5. And that gradient will give us a -6, if I'm not mistaken, because it's -12 over 2, which is -6. Once I get the gradient, then I'll need the tangent because it is the angle between the x-axis and the line, and the straight line. So the tangent of beta will be equals to -6. In this case, I see a negative. So what must I do now here? I must write a reference angle. Hope you get that. So I'm going to use shift tan with a positive value, which is 6 in this case. And the angle that I'm going to get is 80,54 degrees. But that angle, if I check that angle here, it cannot be 80. So it's more than 80. So which means that my angle will be 180 degrees minus the reference angle. Then the theta will be equals to 99.46 degrees. That makes sense because it's more than 90 degrees. That angle is more than 90 degrees. So if I see the tangent of an angle being negative, we must know that the angle is more than 90 degrees. So we need to do it this way. I know in some of your school, what the teachers, how the teacher teach it, they'll say shift tan and they put a negative, and then from there, when they get the negative answer, they say plus 180. Well, if you get this answer, why not? You can still use that. But here, please write down, we know we don't work with negative angles in technical maths, so please use that. We use the reduction formula, but obviously if we don't, we put it as a negative angle, the reference angle is a negative angle, and then in technical maths we don't work with negative angles, then we have a bit of a challenge in terms of marking there. So please, let's do it correctly. If you do it if you do it like that and say shift tan -6, and then from there you say plus 180 without writing it down, then you write down the final answer, well, that's fine. But once you write down negative angles, then we have a challenge with it. All right. That question again, this one, it's quite easy also. The a squared here, remember the a squared is 3 squared, which is 9, meaning that our a will be equals to plus or minus 3, because the square root of 9 is 3. The b squared here is 36. Then we have got b, which is plus minus 6. Right? So we go to our Cartesian plane. The a represents the x-axis, so the a is 3. So from the 0 here, we're having 1, 2, 3. Then we're having 1, 2, 3. Then for the b, which is the y-axis, we're having 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Put a cross. Then from there you write down your 6 here, your -6 there, your 3 here, and your -3.